able to predict correctly. Mm, yes, sir. And then we had used MANOVA also, multivariate analysis, uh, to do the classification checking also. Yes, sir.
So today we will learn about the difference between logistic and linear regression, and we learn the applications of the logistic regression also. Now, the linear regression and logistic regression are two fundamental statistical techniques. Is it visible now? Or
Yes, sir. It is visible.
yeah. So the linear regression and logistic regression are two fundamental statistical techniques used in predictive modeling. So when we are talking about the regression, so regression as is used for the prediction purpose, but they serve different purposes also. For example, the classification. Linear regression is used when the dependent variable is continuous, meaning it can take any numerical value. So I have discussed the metric and non-metric data earlier. So when it will be the linear regression, that means you are following the metric data. And when you are following the binary regression model, that means you are following the categorical data or the non-metric data. Or the logistic regression. In case of the linear regression, we assume the straight line equation. Expressed as y equal to a plus bx plus e. Here y is the dependent variable, a is the intercept, b is the coefficient, and x is the score. E is the error. This model assumes that the relationship between the variable is linear and the errors are normally distributed. It is commonly used for predicting numerical values such as house prices, sales trends, and financial risk. This is clear now.
Yes, sir. This is clear.
On the other hand, logistic regression is used when the dependent variable is categorical, typically binary, for example, 0 or 1, yes or no, pass or fail. instead of predicting a continuous value. Logistic regression estimates the probability of an event occurring using the sigmoid function. In the earlier class, I have discussed the sigmoid function, that is the S pattern we get. So what is our target? That is P means the probability. Y equal to 1. Y means dependent variable. Y is equal to 1. So 0 means fail, 1 means pass. Suppose this is the assumption. So we have to follow this particular model. Next, the E. E is Euler's number, 2.718, the base of the natural logarithm, which ensures a smooth nonlinear transformation. Then beta O. Beta O means the intercept, representing the baseline log odds when all independent variables are 0. Log odds that indicates the baseline, that means fail or pass. Suppose this is the two dichotomy. And the beta 1, the coefficient for the independent variable x, indicating how changes in x affect the log odds of y equal to 1. So log odds y equal to 0 means baseline. And y equal to 1 means event line. That is the complete line. X is the independent variable or the predictor, which influences the probability of the outcome. Here outcome means y. This function helps transform any linear equation into a probability value, which is crucial for classification problems in logistic regression. So logistic regression we usually follow when our interest is to predict the classification. So what is the probability for pass and what is the probability for failure? In psychometric, suppose you have the data and that data indicates the probability for high mechanical aptitude and probability for least mechanical aptitude. Suppose you are interested to study the probability for mechanical aptitude. That is, what is the probability to be engineer? Or in case of the depression, what is the probability for the depression, high level of depression? And another one is the least level of depression. So you can consider high level of depression means is depression, and least level depression means no depression. So this transformation ensures that the output remains between 0 and 1, making it suitable for classification tasks. Logistic regression is widely applied in medical diagnosis, predicting disease presence, credit scoring, determining loan default risk, spam detection, and employee attrition prediction. So, what is the chance for predicting employee attrition? While linear regression provides direct interpretability by showing how much the dependent variable changes with a unit change in the predictor, logistic regression interprets its coefficient in terms of log odds. Indicating the likelihood of a particular category. Both models are essential in data analysis, but the selection depends on whether the outcome variable is continuous or the categories. So if the outcome variable is categorical, then you can go for the logistic regression. And if your outcome variable is non-categorical, it is metric, then you can go for the linear regression. Here are the some limitations of logistic regression in psychological research. Number one, oversimplification. It reduces a complex psychological condition to a binary outcome, yes, no, which may not reflect the full spectrum of mental health. For example, your depression data. So you are making the arbitrary classification based upon the mean as the cutoff point, or maybe the quartile as the cutoff point. So this can be considered as the oversimplification. Second one, dependence on scale quality. The model's accuracy is only as good as the assessment tool used. If the scale lacks validity, the predictions won't be reliable. If the scale lacks validity, then prediction will be in question. Ignores underlying causes. Depression, for example, is influenced by biological, psychological, and social factors, which may not be captured properly in a logistic regression model. Assumption of linear relationship. Logistic regression assumes that predicted variables, for example, stress, sleep, genetics, have a linear relationship with the outcome, which may not always be true in psychology. So in psychology, when we are making the arbitrary classification, rather than the genuine classification, then this arbitrary classification may be in some question. Where it might be useful. Screening large population. Achha. Assumes a screening large population to identify high-risk individuals, predicting suicide risk in adolescence based on social and emotional factors. Understanding which factors contribute most to a diagnosis. That is, which stressors are strongest predictors of anxiety. There you can use the logistic regression. And using logistic regression, you have to consider some of the limitations. First one assumes a linear relationship. Many psychological behaviors do not follow a straight line pattern, like emotion, thought, and behavior. They often interact in complex and nonlinear ways. Second one, sensitive to outliers. Extreme values can distort the model, leading to misleading interpretation. Number three, ignores interaction effects. Psychological conditions are influenced by multiple interacting factors, which linear regression does not always capture. So if it is a factorial design, then it becomes very difficult for researcher to get the interaction factor or interaction effect. Limited for categorical outcome. It cannot be used to classify individuals into distinct groups. For example, diagnosing depression versus no depression, making it unsuitable for some psychological assessments. Oversimplify psychological construct. Human behavior and mental health conditions involve dynamic, multi-dimensional processes that may not be fully captured by a simple linear model. So where it might be useful, predicting psychological score, understanding how variables like stress, sleep, or social support influence cognitive performance or well-being. So when it will be the psychological test score, for example, the total time taken, that may be your outcome variable. So if it is more than 2 minutes, and whether the below the 2 minutes, below 2 minutes means log odds will be the 1, and above means log odds will be the 0. Analyzing therapy outcome, examining how the number of therapy sessions affect changes in depression or anxiety scores over time. So how many sessions are required? So that is the therapy outcome. Workplace and educational psychology, exploring the impact of job stress of job satisfaction or how study habits influence academic performance. Personality and behavioral studies, predicting traits such as self-esteem level based on social experience or life events. For detailed psychological assessment, more advanced models like machine learning, that is the decision tree neural network, or structural equation modeling, may provide better accuracy and deeper insights. So this is all about the difference between the two and the application of the logistic regression, as well as the linear regression. And I have discussed the advantage, disadvantage, or the limitations of the logistic regression, and when you can use the logistic regression. Besides, I have mentioned some of the advanced models of machine learning that can be used to provide better accuracy and deeper insights about the data. Now it is clear, Vishal?
Yes, sir, this is clear.
Okay.
Sir, just to confirm my understanding, um, logistic regression uh, transforms the linear values into probability or probability odds. That was the word, which gives us an S curve kind of result.
Yeah, that is when you want to make the arbitrary discrimination. In the last class, I have discussed the two types of classification. One is the arbitrary, another one is the genuine. For example, male, female, boy, girl, that is the genuine dichotomy.
Mhm.
Okay.
Yes.
Pass, fail, that may be arbitrary dichotomy.
Mhm.
Okay.
Okay.
So the genuine yes, no, if it is there, then it will be the genuine dichotomy. And if it is based upon the score distribution, and you are making the score as the cutoff point, then that will be the arbitrary dichotomy. Okay.
Yes. Yes, sir.
So you must be very much careful about whether your outcome variable or predicted variable is the arbitrary dichotomy or the genuine dichotomy. Okay.
Okay, sir.
Okay. Thank you. So now I am closing the session.
Okay, sir. Thank you.
Thank you. Welcome.